However, this concentrated load on the columns will cause excessive stress in the soil due to lesser contact area. If this stress exceeds the soil's bearing capacity, it will undergo the punching effect, which leads to imbalance in your structure and eventually cracks or even failure of the whole building. To avoid these failures, you can increase the contact area between the soil and columns. Let's introduce a plate member, that is, the footing, at the base of the column. The load on the column will now be evenly distributed on the soil through plate members. This increased contact area reduces the stress on the soil and the building stands strong. The main job of a structural engineer in a footing design is to find out the area and thickness of the footing. These two factors are determined according to the bearing capacity of the soil present on the site and weight of the building. We have already seen the importance of the footing area. More the weight of the building, wider should be the footing. Additionally, if this structure is subjected to lateral forces like winds, floods, etc., footings will help your building avoid sliding as a result of frictional resistance between the footing and the soil. Now the second design aspect, the thickness of the footing. The footing has to withstand pressure applied by the soil as well. If the footing's thickness is inadequate, the footing on either side of the column will bend due to the soil applying uplift pressure on it. This effect is called applied bending moment. You can see this effect in this FEA result here. To prevent this result, the thickness of the plate is increased. There you go. We have designed a stronger and safer footing for our building.